Hi, everyone. My name is Stephan, and I am a research software engineer at Research Center Jülich in Germany. And I work with Psychoinformatics Lab at INM7 there, specifically with DataLad and its metadata capabilities. And in today's educational course, which is titled How to Write a Re-executable Publication, I will be presenting part of that, and specifically the part that involves DataLad. So I'm going to tell you what is DataLad, and then I'll bring it back to how DataLad can be used with specific examples of commands in order to build or write a re-executable publication. So I'm going to tell you a story with some illustrations, and we start with a team, with a research team. It's a standard research team, and they've just been given this mandate to make their data fair. So that means findable, accessible, interoperable, and reusable. And they have a team leader called Nikki, and they have clinical scientists, they have psychologists, they have neuroscientists, they have research engineers. And they collaborate internationally, and they have data locally, and they might use data from elsewhere, and they want to make this process fair. And they also want to build re-executable publications. Now, these are their challenges. They would like to understand how they can structure their data. They have data in different places. They have a local server. They have hard drives with data. They have things that must still be digitized and added as metadata. So they need to figure out how to store their data. Do they need to change that? But when it comes to structure as well, how do they structure their data? Is it different formats, different data sets that's in a specific hierarchy? And how are these data sets linked? And how are they transported? If they have data that's in the cloud or on server, do they copy it before they analyze it? And then push it back, copy the results back, and how do they track the changes when they analyze this data? So can they revert easily back to the previous version if they realize, oh, we made a mistake with this specific analysis pipeline? So these are the challenges, and they search for a solution. They come across this product called DataLad. So DataLad is an open source tool. It's a command line tool, and it's available for free. And it also has a Python API. So you can install it on all the major operating systems. And Nikki and her team, they do that. They install DataLad, and now they want to start using DataLad. So let's figure out what do they want to do. Now, at the core of DataLad, we have a DataLad dataset. And this dataset is a modular unit that consists of a Git repository for version controlling your file content, everything that's part of a dataset. And a dataset is just files in a directory tree. So your DataLad dataset consists of this Git repository, but also of the annex. And this is managed by Git annex. And the reason for splitting these up is to make the dataset itself modular and small and lightweight, but can still represent the full content of your data, whereas the content itself can then be stored in an annex. And this is used for large file storage and management. And by separating these two, you make the whole ecosystem much more extensible. So you can, for example, put all of this lightweight dataset content, the lightweight dataset that describes the data in the dataset somewhere accessible that people can find, and they can understand what the data looks like and what file tree looks like. But the content can be kept elsewhere such that you can, for example, store it securely and encrypt it and behind access control. But you can still keep the core part of being able to track the changes to your data. Now, this track changes is based on Git. So if you're familiar with Git, DataLad does the same. It adds a layer on top to make this usable in a data processing friendly or data management friendly way. And it has the standard functionality of with Git, you can create branches of your data. You can add changes, you can commit them and merge them back such that you have a new version. And at the end of that process, you can just run a data.let save in your command line, and it creates the exact state of the new version and who committed that state and what exactly changed. Now this part opens up, or data.let specifically opens up your whole process for decentralized collaboration. So you do not have to depend on a central data infrastructure and manage everyone's access to that. And sometimes it could be physical, that people have to go to a place in order to download data if safety is such a concern, or they can only process it there. The decentralized collaboration of Git is now opened up for your data. So if Nikki manages her data sets as data.let data sets, she can decide that the Git annex part is pushed to the local server, which might have access to some network. But the data set, the data.let data set part is then made available on some public repository, for example, GitHub. And in this way, her colleague that's on the opposite side of the globe, Priya, can clone the data set. So it clones the lightweight data set. It doesn't get all of the content, but it gets enough to be able to say, this is what the data tree looks like. These are all the supposed files in the tree. And when you get down to a file, you cannot open it, but it points to, it's a symbolic link that points to the actual data location. And data.let can, if you then run data.let get a specific file, data.let can get everything for you. Under the hood, it takes charge of the transportation mechanism. It asks you for access credential if it's needed. For example, if Nikki provided access credentials to Priya to that specific server where the data is located, she can enter those and she will get the file that's necessary. Something else that data.let also does is capturing dependencies and provenance. And what this means is something that's very useful for our goal of creating a reproducible article or publication. Now, when you want to do something like that, is you often start with data, input data. You then have an analysis pipeline that could be a script, a shell script, a Python script. It could be a full containerized pipeline that contains the full environment that people would need to run this analysis. And then you end up with an output data. Now, with data.let, you can use dataset nesting to capture these dependencies. So if you create a new dataset that is now called our publication dataset, for example, I create a sub dataset that tracks the changes or tracks the version of the container. That is a dataset. I create a sub dataset that tracks the version of the actual input data. And then I can run the analysis. And I use data.let run to do that. Because when I use data.let run, and I, for example, point to the input data and to the container, the outputs that are generated can also be saved as a sub dataset in the publication dataset, but the provenance record specifically is saved. So this means, this provenance record is tied to a specific run command, and that run command is tied to a specific commit hash. So data.let can very specifically identify which version of the code was run on which version of the input data to generate which version of the output data. And then finally, all of this new content that was generated and that was saved as a data.let dataset can be pushed again back to where the original input data, for example, was located. So say Priya has done all of this on the other side of the globe. Nikki can then update this dataset. So say she cloned the publication dataset, but originally only contained the input data, and Nikki has added the container and she's added the output dataset. Priya has added all of those things, and Nikki can now update this dataset. She gets all the new content, specifically the data.let dataset, the lightweight modular datasets, not necessarily the content. But she also gets the provenance record of that run command that Priya ran. And Nikki wants to specifically rerun this. She wants to make sure that it's reproducible for them locally. because they need to run it in future again. And then she just takes that commit hash that points to the provenance record. She says datelet rerun and generates the same output data. And these can be compared and be shown to be reducible bit by bit. Datalad is not, let's say, a data management system that replaces existing things. It's made stronger by its integrations to existing things. So it integrates with all the major code and data hosting services. Amazon S3, Dropbox, a lot of us know OpenEuro here. OpenEuro datasets are Datalad datasets. You can clone OpenEuro datasets and get the content just purely with Datalad. So this means that people do not have to uproot the whole infrastructure that they built around specific server and data storage processes in order to use Datalad. They can just let Datalad integrate with that. And then finally, we have some resources here. And specifically, I want to point to the Datalad handbook, which contains all of what I've said just now, but in much more detail and much more carefully described way, with walkthrough examples and code that you can run, and examples of specific data storage servers and services that Datalad integrates with. So have a look. Now, getting back to the publication, we have to do a lot of what I just explained for building a re-executable publication. Firstly, we have to access data, input data. We have to run a specific analysis with that input data, and then we can save the outputs and push that somewhere such that other people can re-execute that publication. So with accessing data, we do a Datalad clone. And here's, for example, a pointer to an OpenEuro dataset. So this is a Git repository, lightweight, and clone it. It gets all of the data set, it gets the lightweight data set locally, and then you can point to a specific file to get it. That's an example. And then once you're finished, the nice thing about Datalad, you can just drop that content as well. So you don't have to download the full data set, then use a part of it, and then have all of this extra data there. You can just get what you need and drop it once you're done. You have to generate results after you have the data. And in order to do that, if you specifically want to run a containerized pipeline, you have to have a Datalad extension called Datalad container. And you can install it with pip or conda. And then you also have to have the container itself. And there's an example of a set of repronym containers where one of them will be used as a pipeline to run on the input data. And the command we use here is Datalad containers run. And that captures a run command provenance record. And once it's done, we can rerun that by using the commit hash of that run command. And then also to publish data, we can publish data in multiple places. So we can publish the lightweight repository on GitHub. So that's done by saying Datalad creates sibling GitHub. We call it, for example, Git LFS, because we want to publish the annexed contents on Git LFS. And Git LFS is a large file storage. It's a way to store large files on GitHub, as opposed to the data storage on Git itself, which has a gap. Now, the way to do that is to create a special mode of type Git LFS, and this is done with Git annex as an example command. And we have a walkthrough in the handbook that specifically explains a bit more about this that you can run through in detail. And then if that is created, it's very easy to copy the contents to Git LFS and to push the Datalad dataset to GitHub with these commands. But you can also combine them. So if you, for example, create a publication dependency, always when we want to push to GitHub, we also want the file contents to go to the annexed location. Then we make the GitHub LFS a dependency of pushing to GitHub. And this is the way that is done. Datalad siblings with the publish depends flag. And then finally, just Datalad push to GitHub. And that puts your data where it needs to be, and it puts your lightweight repository where it needs to be. And that kind of summarizes what we need to do for re-executable publication and what you will be doing or similar steps that you will be doing for this workshop. Thank you.